Before there were continents, borders, or the lines that divide oceans from land, there was only mystery, a horizon unmeasured, a sky without shape, and a sea that no man had yet dared to chart. In that age of wonder, when myth was still the language of truth, a young Greek from the Ionian coast looked upon the world and asked a question that no one before him had ever asked. What is the shape of the earth? He was Anaximander of Miletus, philosopher, geometer, and the first human known to draw the world as a map. His curiosity became a spark that lit the dawn of science. From the dust of his coastal city in ancient Asia Minor, he began to transform human thought from poetry to reason, from myth to measurement. The story begins in Miletus, around the early 6th century BCE. The city stood on the western edge of Anatolia, facing the Aegean Sea, a crossroads of merchants, sailors, and thinkers. Ships from Egypt, Phoenicia, and the islands of the Aegean arrived daily, carrying goods, languages, and ideas. In this vibrant port, knowledge traveled faster than armies. Here, a generation of thinkers emerged who would change the way humanity understood nature forever. Miletus was the cradle of what historians call the Ionian Enlightenment. Among its citizens were men who abandoned mythological explanations and began seeking rational causes for natural phenomena. Thales, the elder philosopher of Miletus and mentor to Anaximander, had taught that water was the fundamental substance of all things, the arche, the origin of existence. Anaximander, however, was not satisfied with a single material cause. His mind reached for something deeper, something boundless, the aperon, an infinite principle beyond the elements of earth, air, fire, and water. He was born around 610 BCE, in a society that still revered Homer's gods yet increasingly valued reason. In the agora, the market square, people debated about trade and taxes, but in the courtyards of scholars, another debate unfolded, about the nature of the universe. While others saw the sun as the chariot of Helios, Anaximander sought to measure its height. While others described the ocean as the realm of Poseidon, he wanted to know where it ended. From his youth, he was fascinated by the motion of shadows and the curve of the horizon. It is said that he built the first known gnomon in Greece, a vertical rod that cast shadows to mark the hours and track the solstices. Though simple, this instrument was revolutionary. It connected the heavens to human understanding. Through its shadow, time itself could be measured. Standing upon the white stone terraces of Miletus, Anaximander would watch as the shadow of the gnomon moved across the ground, tracing invisible geometry upon the earth. In those slow arcs of sunlight, he saw a pattern, the movement of the heavens obeying laws that were not divine, but natural. And if the sky could be measured, perhaps the earth could too. His curiosity led him to question the ancient assumption that the world was a flat disk resting upon the back of some cosmic creature, or supported by pillars of the gods. Instead, he imagined Earth suspended freely in space, balanced at the center of all things. This idea was breathtakingly modern. He reasoned that since the Earth had no reason to fall in one direction more than another, it must remain at rest in the center of the cosmos, an equilibrium of infinity. To visualize his discovery, Anaximander did something no one had ever done before. He drew a map of the known world. With a stylus on waxed board or papyrus, he began to outline the lands described by sailors and travelers: the Mediterranean basin, the lands of Asia, and the mysterious expanse of Libya to the south. For the first time in human history, the world took shape as a picture. Though his map is lost to time, later writers like Hecataeus and Herodotus described it as a circular diagram, with the Aegean Sea at its heart, and the surrounding continents arranged like petals of a vast flower. Europe lay to the north, Asia to the east, Libya, Africa to the south, all encircled by the great river Oceanus, the mythic boundary of the world. But what made Anaximander's map extraordinary was not its geography, but its philosophy. In drawing it, he proclaimed that the world could be known by observation and reason. Every coastline he traced, every island he positioned, was a declaration of faith in human intellect, the belief that reality could be understood, not merely imagined. Anaximander's curiosity did not end with the earth. He looked upward to the heavens and began to describe the cosmos as a system governed by natural laws. He imagined the stars as rings of fire, hidden behind invisible wheels, each pierced by openings through which the flames shone. The constellations. The sun, he proposed, was a circle of fire 28 times the size of the Earth, its light emerging through a single hole. The moon, smaller and nearer, glowed by reflecting sunlight. Though these details were imperfect, the framework was revolutionary, the first mechanical model of the universe ever conceived. His notion of balance extended to the world's origin. In his lost treatise, On Nature, he described creation not as the act of gods, but as the separation of opposites, hot and cold, wet and dry, light and dark. From the boundless Apiron, these forces emerged, giving rise to the heavens and the earth. In this way, he replaced mythology with natural philosophy. When he taught his students, Anaximander spoke not in hymns but in reasoning. He explained that thunder was not Zeus's anger, but the clash of clouds. That rain was not divine mercy, but the condensation of vapors. That life itself may have originated in the sea, from creatures that gradually adapted to land. These ideas would echo millennia later in the theories of evolution and cosmology. In Miletus, his contemporaries might have found him eccentric, a man who walked the harbor at dawn, asking sailors to describe distant shores so he could measure the distances in his mind. But Anaximander was constructing something greater than a chart. He was building a framework of thought. His map of the earth was a metaphor for the human mind mapping the universe. Around him, the Aegean world was alive with discovery. Phoenician merchants brought tales of the Red Sea. Egyptian scribes spoke of the Nile and its flood cycles. Babylonian astronomers shared their celestial records. From all these encounters, Anaximander gathered data, not myths. He compared the stories, seeking consistency. He noted where the sun rose earlier, where shadows grew longer, and how climates changed with latitude. Step by step, he transformed hearsay into measurement. The people of Miletus may have first seen his map displayed in the public square. A circle inscribed upon parchment, painted in earth-colored pigments, the known world floating upon the boundless waters. To the crowd, it was a curiosity. To Anaximander, it was a mirror of the cosmos. His teacher Thales had once predicted an eclipse, a feat that astonished the Greeks. But Anaximander's achievement was quieter, more enduring. He gave humanity a way to see itself in space. His world was not a mythic island surrounded by gods, but a real earth surrounded by wonder yet to be explored. As night fell over Miletus, the stars rose above the dark Aegean. The philosopher would gaze upward, not in worship, but in study. Each point of light was a coordinate, each constellation a question. The world, he realized, was both infinite and knowable, and somewhere in that paradox lay the beauty of truth. The next morning, he returned to his map, correcting coastlines, redrawing islands, refining the curve of the known world. Each line was a conversation between the human mind and the vastness of existence. It was the first dialogue of science, not spoken in words, but in geometry. Centuries later, when Greek geographers like Eratosthenes measured the circumference of the Earth, and when Ptolemy charted the stars, they were walking the path Anaximander had opened. Every atlas, every globe, every satellite image that now circles our planet carries a trace of that first drawing in Miletus. Anaximander's map is lost, but its idea endures. The belief that by observing, reasoning, and drawing, humanity can transform ignorance into knowledge. The boy from Miletus, who once watched shadows, now cast a shadow across history itself. A shadow not of darkness, but of awakening. The earth, once bound by myth, had been freed by the mind. The sea wind swept through the marble courtyards of Miletus, carrying the scent of salt and olives. It was the hum of a city alive with trade, with argument, with the noise of shipwrights and scholars. Here, in the 6th century BCE, ideas traveled as swiftly as cargo. To Anaximander, the movement of ships across the sea mirrored the movement of stars across the heavens, patterns guided by invisible laws. He saw in every rhythm of nature a hidden order. The tides, the winds, the seasons, none were ruled by divine whim. They followed principles that could be reasoned and measured. For the first time, the human mind was daring to see the universe not as a stage for gods, but as a system governed by balance. In his surviving fragments, Anaximander described this balance with a single, haunting sentence: "Things perish into the elements from which they came, for they pay penalty and retribution to one another for their injustice, according to the order of time." It is perhaps the earliest philosophical expression of natural law. The idea that the cosmos maintains justice through equilibrium. Hot yields to cold. Night returns after day. Life is born and returns to dust. The universe was not chaos but harmony, a self-correcting system. This insight echoed far beyond his own lifetime. It laid the foundation for what the Greeks would later call cosmos, an ordered whole. For Anaximander, this harmony extended even to the shape of the earth. He imagined it not as a disk floating on water, but as a cylinder suspended freely in space, equidistant from all things. This was a radical thought in an age when most people still pictured the world as flat. Yet Anaximander's reasoning was profound. The earth does not fall because it is balanced in the center of the universe. Nothing supports it, because nothing needs to. It simply remains where equilibrium dictates. More than 2,000 years later, Newton and Einstein would describe gravity and relativity with a similar intuition, that forces, not pillars, define motion and rest. Anaximander's cosmos was also geometric in structure. He believed the heavens revolved in concentric circles, with the stars nearest, the moon next, and the sun farthest. He calculated their relative distances, creating a scale model of the universe. It was not exact, but it was the first attempt in human history to place the Earth within a measurable space. In doing so, Anaximander transformed the heavens from divine mystery into a map of order. To him, The cosmos was architecture, vast, symmetrical, and governed by proportion. The sun and moon were not gods, but luminous wheels of fire. Eclipses occurred when their apertures closed. The stars moved not at random, but in harmony, their circles forming the celestial geometry that mirrored the logic of Earth. This transformation, from myth to model, was one of humanity's greatest intellectual revolutions. The cosmos became a subject of study, not superstition. From this point onward, Greek philosophy would carry the conviction that the universe is intelligible. Anaximander's influence soon reached the next generation. Among his students was Anaximenes, who continued the search for a primary substance, suggesting that air was the element of all life. But Anaximander's deeper legacy was not in materials, it was in method. He had shown that observation, reasoning, and drawing could reveal truths once hidden behind myth. To understand the scale of his innovation, one must remember that no other civilization before him had drawn a rational world map. Babylonian clay. Tablets showed schematic views of the world as a circular plane, but they were mythic in nature, centered around temples and divine mountains. Egyptian and Near Eastern cosmologies depicted Earth as a rectangle beneath the sky goddess Nut. Yet Anaximander's world was not divine, it was measured. His map was not just a picture, but an argument. The Earth could be represented in relation to itself. From that idea flowed everything we now take for granted: navigation, geography, cartography, astronomy. In the Agora of Miletus, his drawings inspired curiosity. Children gathered to see where the edges of the world lay. Sailors debated the shapes of faraway lands. Even the elders, who distrusted novelty, could not deny that something in the way Anaximander thought felt inevitable. By reducing the unknown to line and proportion, he had given the human mind a tool, a way to see the invisible. And in time, that tool would reshape civilization. As the decades passed, Anaximander's influence rippled outward like waves. Hecataeus of Miletus, one of the first historians, used Anaximander's framework to create an improved map of the known world, labeling regions with the names of tribes and rivers. He traveled widely, verifying locations and distances, turning Anaximander's abstract idea into a practical science. Later, Herodotus, the father of history, would describe lands and peoples across Asia and Africa with geographical precision, a direct descendant of that first map drawn in Miletus. Even Aristotle, centuries later, would call Anaximander the first to attempt an explanation of nature as a whole. But Anaximander's genius lay not only in geography or cosmology. He was also among the earliest to conceive of evolutionary development. In his lost writings, preserved only through fragments quoted by later philosophers, he proposed that life began in moisture, that humans and animals originated from aquatic creatures enclosed in shells. As the sun dried the waters, these creatures adapted to land. Humanity, he suggested, came from earlier forms that could survive without parental care. It is astonishing to realize that more than 2 millennia before Darwin, a man in a small Ionian city proposed that life evolved from simpler organisms. His reasoning was purely naturalistic, not divine creation, but transformation through environment and time. This too flowed from his faith in observation. He had seen fossils of marine life in inland rock, the marks of seas that once covered the land. To him, this was evidence of change, of the world's deep and dynamic history. His worldview was not a religion, but a revelation. The revelation that nature explains itself. The gods, in his philosophy, were not supernatural beings but eternal forces, the hot, the cold, the moist, the dry. They were principles, not personalities. This approach marked the true birth of scientific thinking. To ask why in terms of cause rather than intention was to open the door to logic, physics, and astronomy. The Greeks called this kind of explanation logos, and in Anaximander's time, it was a new language, the language of reason. He also introduced the concept of cosmic justice, where the elements make recompense for their excesses. It was a poetic metaphor for balance, yet behind it lay a physical truth, the conservation of equilibrium. Fire consumes, but air restores. Drought follows flood, but both sustain the cycle of life. In this sense, Anaximander can be called not only the first geographer, but the first ecologist, recognizing the world as a system of interdependent forces, not isolated acts of will. He taught that everything returns to the apeiron, the infinite source of all things. This word, meaning the boundless, became a cornerstone of Greek philosophy. The apeiron was not chaos, but potential, eternal, indestructible, and inexhaustible. From it, the cosmos emerged, and to it, all things would return. This vision of an eternal cycle, creation, destruction, renewal, resonated deeply in the Greek imagination. It shaped the later philosophies of Heraclitus, with his doctrine of perpetual change, of Empedocles with his elemental forces, and of Stoicism with its universal reason. In this way, the map-maker of Miletus became the architect of thought. Imagine him in his later years, gray-bearded, his eyes still bright with curiosity, walking along the harbor as ships departed for Egypt and Phoenicia. He would listen to their tales and trace their routes in his mind, comparing them to the circles he had drawn long ago. Perhaps he smiled to think that each voyage expanded the edges of his map, and with it, the frontier of knowledge. He knew that the map was never complete. The world was larger than any parchment, and truth was larger than any man's understanding. Yet every discovery, every line drawn by the next generation, would rest upon his foundation. When later philosophers spoke of cosmos, they spoke in his voice. When astronomers plotted the heavens, they used his geometry. When geographers divided continents, they followed his circle. Even Pythagoras, who came after him, carried forward the idea that the universe was built upon number and proportion, a notion that may have begun in Anaximander's study of shadows and circles. Centuries later, when Eratosthenes measured the circumference of the Earth using the angle of sunlight in Siena and Alexandria, he was perfecting a vision that began with Anaximander's gnomon. And when Copernicus placed the sun at the center of the cosmos, freeing the Earth from its fixed throne, he was echoing the same courage, to look beyond myth and see the universe through reason. For Anaximander, this courage was not arrogance, but wonder. He did not see science as the rejection of divinity, but as the discovery of its deeper form, the beauty of order. The world, to him, was sacred precisely because it was intelligible. As the light of evening spread across the Aegean, Miletus glowed with the soft gold of oil lamps. In the academy's courtyard, young students gathered around a stone table where a circular map lay open. They whispered about distant lands, about the Nile and the Euphrates, about the mountains where the sun was said to rise. Anaximander, seated among them, listened quietly. Then, with a reed stylus, he drew a new line. Faint, uncertain, but daring. That line was more than a boundary. It was a gesture of faith in human reason. He believed that the universe was not hostile to understanding, that the same logic governing the heavens also lived within the human mind. To seek knowledge was to participate in that cosmic order, and thus his philosophy became a way of life. The pursuit of harmony between man and cosmos. When later historians spoke of the Greek miracle, they referred to this awakening, the moment when thought turned inward and asked, "What if the world can be known?" That question began in Miletus, in the shadow of Anaximander's gnomon. The story of humanity's intellectual journey, from maps to mathematics, from stars to atoms, began with that single act, drawing a circle on parchment and saying, "This is the world." The old philosopher's teachings continued to echo long after his death, carried by generations who saw in him a prophet of reason. The city of Miletus eventually fell to the Persians, its libraries burned, its schools scattered. But ideas, once born, do not die with cities. They travel, as light does, across time. And so the thought of Anaximander, the thought that the world has structure, that knowledge is possible, survived through centuries of conquest, through the rise and fall of empires, through the silence of forgotten ages. It would reappear in Alexandria, in Rome, in Florence, in every place where someone looked at a map or gazed at the stars and felt that same ancient curiosity. In the quiet of night, under the endless sky, one can still imagine that Ionian thinker standing beside his gnomon, watching the shadow fall. Each inch of movement measured not only the turning of the earth, but the awakening of the mind. For in measuring the world, Anaximander measured humanity's capacity to wonder. The light of dawn spilled across the Ionian coast. Miletus awoke to the song of gulls and the steady hum of the sea. In that hour between darkness and day, when the horizon blurred between water and sky, the world seemed vast and endless, exactly as Anaximander once imagined it. Generations had passed since his time, yet his circle, the symbol of Earth surrounded by ocean, remained etched in the collective memory of Greece. The map he drew was no longer just ink on parchment. It had become a new way of seeing reality itself. From the harbors of Ionia, this vision spread like ripples on the sea. Greek sailors carried it to the Aegean islands, to Crete, to the Cyclades, to distant Sicily and the coasts of Italy. In their minds, navigation became not only a matter of instinct, but of geometry. Each voyage began to align with lines and distances, the logic of Anaximander's imagination. The sailors no longer thought of the ocean as an endless abyss of gods and monsters. They began to see it as a measurable expanse, divided into known and unknown, charted and uncharted. It was the first transformation of fear into curiosity, the shift from mythic ocean to geographic world. In Athens, philosophers took his ideas and wove them into new fabrics of thought. Pythagoras saw in the same circles and spheres the harmony of the cosmos, that the universe itself could be understood as music and number. Heraclitus, meditating on the eternal flux of things, found resonance with Anaximander's belief that the elements make recompense to one another through balance. Even Plato, 2 centuries later, when describing the Earth as a sphere suspended in space, echoed the same daring vision that began in Miletus. Yet the most remarkable thread of Anaximander's legacy ran through the hands of Eratosthenes, the librarian of Alexandria. More than 250 years before Christ, he measured the Earth's circumference using shadows and sunlight. The very principle Anaximander had once used to mark time with his gnomon. When Eratosthenes placed his measuring rods in Cyane and Alexandria, he was continuing the same lineage of curiosity. The ancient Ionian's shadow had become a global compass. From that experiment, the size of the Earth was no longer a mystery. It had been calculated, a triumph of observation, geometry, and faith in reason. But between these great names, between Miletus and Alexandria, lay centuries of transformation. Empires rose and fell. The Persians conquered Ionia. Athens burned and rebuilt. Alexander the Great marched eastward and brought Hellenic thought to Babylon and beyond. Through it all, the memory of Anaximander's world, a balanced Earth, a rational cosmos, quietly endured. His map inspired the cartographers of Hecataeus and later Ptolemy, whose Geographia became the cornerstone of ancient and medieval mapping. It influenced the astronomers of the Hellenistic age, who placed the earth and heavens in systems of circles and spheres, and in time, it guided explorers who would sail beyond the known world, tracing coastlines once only imagined. But perhaps the most enduring part of Anaximander's work was not his geography. It was his idea of order, the notion that nature could be understood through observation and principle was revolutionary. He had given humanity a new relationship with the world, not as subjects beneath gods, but as participants in a rational universe. This idea spread across centuries like a hidden current. It resurfaced in Aristotle's natural philosophy, where every change had a cause and every motion a purpose. It inspired the Stoics, who saw divine reason, logos, in the structure of the cosmos. It shaped the medieval thinkers who sought to reconcile faith with reason, believing the universe reflected order because its source was rational. And ultimately, it resurfaced in the scientific revolution, when thinkers like Copernicus, Kepler, and Galileo reclaimed the idea that the universe follows knowable laws. Anaximander had lit that first torch. He may have never imagined telescopes or globes, or the mechanical clocks that would later trace the heavens. Yet every one of them carries the spark of his insight. That measurement reveals meaning. Imagine now a modern astronomer, standing beneath the same sky Anaximander once studied. She raises her telescope toward the Milky Way, where billions of stars form spirals of light. In her equations and her maps, she traces the same questions that drove the philosopher of Miletus. Where are we? What holds us? What does it mean to exist in balance? Across 2.5 millennia, the tools have changed, but the wonder remains the same. The story of Anaximander is not merely ancient history. It is a mirror of the human condition. He lived in a world small in geography but vast in imagination. His universe had no gods of thunder or seas, only the cold beauty of proportion, the eternal rhythm of transformation. To him, knowledge was not possession, but participation. To know the world was to live in harmony with it. That is why his philosophy never lost its spiritual depth. Even as it removed the divine from the sky, It made the world sacred again by making it understandable. The Greeks who followed him understood this balance between reason and reverence. For in discovering the structure of the cosmos, they did not destroy its mystery. They deepened it. The more they measured, the more they realized how vast, how elegant, how interconnected everything was. When we look at his map today, the circle of the known world surrounded by ocean, we see not its simplicity, but its courage. It was humanity's first attempt to say, this is where we are. Every map since, from the parchment scrolls of Ptolemy to the digital atlases of our age, is a continuation of that gesture. Even the world maps we hold today, blue oceans, green continents, carry a trace of that first line drawn in Miletus. Without Anaximander, there would be no latitude, no longitude, no global frame to measure our place. He transformed geography from storytelling into structure, from myth into mathematics. Yet his true gift was not the map itself, but the mindset that created it. The courage to replace belief with observation, to trust the evidence of nature more than the authority of tradition. For the students of history and science, this courage remains the cornerstone of inquiry. Every experiment, every equation, every diagram begins with that same quiet defiance. The refusal to accept the unknown as unknowable. Anaximander's life was a testament to this defiance. In an age when divine explanation ruled, he looked at the sky and said, "There must be reason." He was among the first to believe that the universe could be drawn, not imagined, not feared, but drawn. And in drawing it, he gave humanity a tool to understand itself. His philosophy of balance, of justice among the elements, reminds us today that the same harmony must exist between humans and the planet we inhabit. The cycles of nature he described still govern us. The rising and falling of temperatures, the rhythm of seasons, the balance of water and air. To disturb that harmony is to forget his lesson, that every excess brings its retribution. Anaximander's voice, though ancient, speaks urgently to the modern world. In the warming of seas, in the shifting of climates, in the fragile balance of ecosystems, we can still hear the echo of his words. Things perish into the elements from which they came, for they pay penalty and retribution to one another for their injustice. In those words lies both a warning and a hope that harmony can be lost, but also restored. Perhaps that is why his story still matters. It is not merely about the past, it is about our future, to draw the world once again, with science, with respect, with awareness, is to continue his legacy. When the night falls over the Mediterranean and the constellations appear, the same sky that once inspired him stretches overhead. Somewhere beyond those stars, beyond the Milky Way, lies the infinite Apiron he imagined, the boundless realm from which all things arise. And here, beneath it, humanity continues to draw, to measure, to learn. It is said that when the philosopher Thales, Anaximander's mentor, was once mocked for falling into a well while gazing at the stars, he laughed and replied that he was studying the heavens. Anaximander inherited that laughter, the joy of wonder. For in every line he drew, in every circle traced upon the earth, he was not merely mapping geography, he was mapping possibility. The first map was not just an image of the world. It was a promise that the unknown could become known, that knowledge could expand without end. That promise built the foundation for science, navigation, and civilization itself. In this sense, Anaximander's map was not the end of myth, but its transformation. Where gods once ruled the horizon, now reason ruled. But the awe remained. The sacred had shifted from Olympus to the universe itself. And so, as we gaze upon the glowing arc of our planet from space, the blue sphere suspended in the dark, we see Anaximander's vision fulfilled. The Earth balanced, unsupported, equidistant from all things, held not by pillars but by the perfection of natural law. The philosopher of Miletus would have smiled to see it. The world exactly as he had imagined it. 2.5 millennia ago, he could not have known that one day humanity would orbit the Earth he once sketched, or that telescopes would peer into galaxies beyond count. Yet his reasoning contained the seed of it all. The belief that to understand the world is to belong to it. That belief still guides us. It leads the astronomer to the observatory, the geographer to the map room, the student to the page. Each, in their own way, continues what began with that Ionian thinker who dared to measure infinity. And so, the story ends where it began, beneath the endless sky, with a man holding a reed stylus drawing a circle. The sea murmurs below, the stars turn above, and the light of reason burns quietly against the darkness. His name is whispered by history, Anaximander of Miletus, the first to draw the world, the first to see the Earth as a whole, the first to imagine that the cosmos could be understood by thought alone. Every map, every theory, every exploration carries his invisible signature. For he was not merely a geographer, nor a philosopher, nor an astronomer. He was humanity's first cartographer of understanding. And as long as we continue to seek, to learn, and to wonder, his map will never be complete. Because his world, our world, is still being drawn. A message from World Map Chronicles. Creating a documentary like this takes a week of research, scripting, and visual design. Every line is built from verified history and cinematic storytelling to make the ancient world come alive again. If you'd like to dive deeper into the full research notes, primary sources, and historical context, all references and reading links are available in the video description.